about that. A few guidelines for today's coffee break. There is an option to click the grid view on the upper right to see more callers, make this a truly interactive experience since we're all together. The chat function is accessible via the bottom bar amongst all the options. So put in your questions and chat comments, and we will definitely get to address those. And we actually please be respectful of each other's opinions and their statements. And again, this is an open forum for conversation. And we ask you are mindful or be mindful of not jumping in over anyone talking. And then feel free to talk without being called upon. If you do have something to say, use one of the reactions below. And we'll make a note if it's like a hand up or a hand raised. And when you're not speaking, we actually keep muted to avoid any background noise that may filter in. So I will be monitoring the Q&A and chat boxes. And from the moment I'm going to mute and stop my video, but it is my pleasure to introduce Chris Ruth to the stage. Chris, take it away.
Hey everyone, good morning. Hope you all can hear me okay. This is pretty interesting. I apologize for the delay in getting started. I'm actually traveling back from the AHR conference in Las Vegas. I've been trying to get back into St. Louis for 3 days, just landed in Dallas. So I'm actually sitting on my airplane right now, but I really wanted to take this time to chat with you all, and I wish it was under a little better circumstances, but I'm gonna give you the best I can. Freddie's going to be running running slides for me today. I got a little presentation to go through here, and once we get through that, I can open it up for some Q&A. So, David, I appreciate the intro. Very well done. Thank you so much. Like you mentioned, we're talking about energy management through building automation. Is where we're going to get started. Freddie, can you bump me forward one? I have a lot of animation in here, so you might have to click a couple times to make it do something. So to really get an understanding of what, of how we're going to manage energy through building automation, we first got to take a quick look at what building automation is. This all comes from a presentation I do that covers building automation as a whole, and this is just kind of one part of it. So if you've seen my fundamentals of building automation presentation before, some of this may be a bit of a recap, but we're going to kind of breeze through what exactly a building automation system is, and that'll give us a better understanding of how we can save energy. So, Freddie, go ahead. So when I was in college, my professors always said that Wikipedia shouldn't be a source used when you're looking for definitions. But in this particular case, Wikipedia actually does a very good job of explaining what building automation is. Building automation is the automatic centralized control of the building's heating, ventilation, air conditioning, lighting, and other systems through a building management system. The objectives of building automation are improved occupant comfort, efficient operation of building systems, reduced energy consumption, operating cost, and improved life cycle of the equipment. So the main focus of that conversation today is going to be on the efficient operation and reduction of energy consumption. But you can see that building automation itself covers many different facets of a building. Ready? So building automation systems, as we say, take control of all components in a building, from your heating and cooling equipment, large equipment, small equipment. They also take control of lighting, door access, security systems, and even larger commercial equipment, plant side equipment like boilers and chillers. Freddie, give it a hit for me. So what we do is we install microcontrollers on each one of these devices, and each one of these controllers has a task to do. Those devices all work individually to accomplish their own individual task, but when we start to put all those together is where we really start to see the building automation portion take place. Ready? We install a primary controller into the system, and that primary controller will actually link all of these other controllers together to form an actual building automation system. Ready? Pull a communication bus throughout a building, and we tie all of these devices together. Now they can actually operate together, they can communicate with one another, and they can kind of complement each other when they're trying to get their tasks done. Ready? So what we do with these primary controllers, you can hit it a couple more times for me. Maybe 2 more. There we go. So what we do is, that's fine, keep going.
Well, ladies and gentlemen, just a couple more minutes. Once again, thanks for your patience. The aircraft gate is just
Captain's
called
talking.
Is this where you want it, Chris, the presentation?
Yep, that looks great. Thank you. So these building automation systems, what we do over the top of them is we design a graphical user interface that allows us to take all this complex data and serve it up to the building operators and managers in a way that's meaningful and easy to use. Okay, we can hit it a couple more times. Keep going, keep going. All right, now we're getting into the exciting stuff. So again, that's kind of a very, very quick 30,000 foot view of what a building automation system is and does. There's a lot more to talk about there, but again, with us focusing on the energy side, we're gonna kind of skip through that. So let's take a look at a couple of the ways that we can save energy using a building automation system. The first one is schedules, and you know, the ability to turn equipment on and off is a big part of what a building automation system does. And while that seems pretty simple, it's oftentimes something that's overlooked in buildings. If you think about HVAC equipment in your home or in some offices, usually they just have a thermostat installed on them. That thermostat may or may not have a schedule in it, but a lot of times it just runs 24/7. When we talk about commercial equipment, they are large energy consumers, especially on the HVAC side. In most commercial buildings, the HVAC accounts for about 40 to 50% of the energy used in the building. So the ability to shut that equipment off is a major way to start saving energy. So we use schedules to be able to do that. These schedules go from the top of the building all the way down to the bottom. Every piece of equipment can be scheduled individually so that we can make sure that we're keeping it comfortable and it needs to be comfortable, and we're not wasting energy during off-peak times.
Right, but it wasn't 160.
Ready?
They updated it by half a minute.
For Emily, I don't know who's clicking. Trend data is another big part of being able to keep track of our energy usage and find out where energy is being wasted. A lot of times people will use trend data in a building automation system just to keep track of issues. Most of them are comfort issues. You look at it, you say, well, it was 75 degrees in my classroom all day, and we can see that information here, and that's all well and good. But being able to really dig and dive into a trend will help you see where you could be wasting energy. For example, you may have a specific space where you set the space set point at, let's say, 65 degrees, right? And if you take a look at your trend, you say, man, it's never getting down to 65 degrees in here. I really want it cold in here. It's never getting there. You take a look at that trend and you realize this equipment is running at 100% all the time, trying to maintain a set point that it just can't reach. All that energy is being wasted. So being able to take that information into account and find ways to make adjustments to your system will keep that equipment from working harder to do a job that it just can't accomplish. Go ahead. Advanced metering and reporting is a great way, and this is kind of on the nose when it comes to energy management, but actually installing sensors and meters that will keep track of that information for you. This kind of goes hand in hand with the trending that we were just talking about, really taking a snapshot look of what your building is doing and when it's doing it. We can also attach alarm parameters to these as well. So if you have a specific time of day where your building is consuming a lot more energy than it normally is, these meters will actually generate alarms that will help you to either diagnose problems or troubleshoot other issues in the building where you could be having spikes in energy consumption. Next. Advanced logic sequences really take some of the basics that we're talking about to the next level. And one that I like to use as an example is with scheduling. As we know, when we talk about scheduling the building, just for some round numbers, if we say a building is going to go occupied at 7 o'clock in the morning, usually what we'll do on the building automation system is start it at 6 o'clock. That way we have enough time to get the building up to comfort before the tenants start arriving. But based on outside air conditions, we may not necessarily need to start that building at 6 o'clock. If it is 70, 75 degrees outside, we could start that building potentially at 6:30. And by starting at 6:30, we cut, again, half an hour runtime out, which doesn't seem like much, but when you compound it over all of the different equipment that you have, and you compound it over a year's worth or even the life of the building, you can start to see some savings there. So these advanced logic sequences really give you the opportunity to take things like those schedules and make some more savings. Another common one that we use is in terms of space temperature itself. And thinking about your place of residence again, the optimal comfort, optimal is kind of a relative term, but between 70 and 72 degrees. So if we set our temperature set point in our space at 72 degrees, it's going to try and keep 72 degrees. But when it's 100 degrees outside, it doesn't necessarily need to be 72 for it to be comfortable, right? We can set our home to 74 and 74 still feels comfortable. It's 2 degrees up, we see some energy savings. Same thing on the other side, right? When it's 0 outside, 68 in our home feels comfortable. So what we can do with these advanced sequences, is we can say, based on outside air temperature and current conditions, we don't necessarily need this space to be 70 degrees or 72 degrees. We make these adjustments, we save more run hours, we reduce the amount of energy used to maintain a temperature that we don't necessarily need. Next one. Retro commissioning is one of my favorites. These building automation systems, just like any other piece of equipment or computer, has to be maintained. And when engineers design these systems, they design them to run under optimal conditions. And most HVAC equipment and building automation equipment can last about 15 to 20 years. So when you get 5, 6, 7 years, 10 years into a building, there's a lot of changes that have been made throughout the life of the building to that point. Done that were intended to be energy saving measures, and we've kind of lost some of those. So by retro commissioning a building, we can actually go back in and reset the parameters of the building automation system to where they were originally designed, and that'll help you to save the energy that was originally intended to be saved. And then preventative maintenance is the last part. This is, again, just like anything else, a car, a computer, anything else that needs to be maintained. And if you just install a building automation system and you don't make any updates to it, you don't verify that it's reading properly, that your sensors are reading properly, that all your components are functioning properly, you'll see a lot of wasted energy. A good example that we see here is failed actuators on outside air dampers or valves. If you've got an outside air damper that the actuator fails in the open position, you could be bringing in 10 degree, 15 degree outside air. And if you don't need the air that cold, your piece of equipment is going to run harder to bring that air up to temperature. If those actuators are functioning properly and you're cycling your 70 degree air back through the air handler, it doesn't have to work as hard. So we see a lot of wasted energy when you have components fail, and the preventive maintenance and inspections will help catch those problems, address those problems, and then again, get everything running back in optimal circumstance. Go ahead. I think that's my last one. Yes. I was out of breath. I cooked it through that one. So that's it. And again, I've taken a lot of information, crammed it into a very small window. I'm happy to elaborate on any part of that and answer any questions that you all may have about building automation or energy savings or anything like that.
Well, Chris, thank you so much for that very wonderful presentation. It's especially hard in the setting of an airplane to be so fluid. But
this is definitely a first for me. I have not done a live Zoom from an airplane before.
That's something I would put on the resume. Absolutely. But,
yeah, definitely.
There is something in the chat. Let's see. Yeah, I think a lot of people echo the sentiment of you doing a great job given the circumstances. One question that kind of came to my mind, how much savings can be expected when building automation is added to an existing building?
So that's kind of a $1 million question, and one that I get asked pretty regularly is how much can we expect to save? And based on the equipment in a building, whether it's all package equipment that's just using airside equipment, whether you have larger commercial plants that have a lot of water side equipment like boilers and chillers, that number kind of varies. Typically, the number that we will throw out is 10 to 15% is about what we expect to see by adding building automation. But again, that changes. If you think about, I did a system on a church just recently. They had an air handler for their chapel, and that air handler ran all the time. It was always 72 degrees in that chapel, 24 hours a day, 7 days a week, 365 days a year. This particular chapel had a Wednesday night service, had a couple of services on Sunday, and was used for choir practice one night a week. So the amount of hours that we were able to reduce on that particular piece of equipment was a very large savings. That's not always the case with everything, but again, it all kind of varies based on the equipment, the runtime. But normally we say about 10 to 15% is what is kind of the plug number we use for that.
Thank you for that. That's wonderful. And a couple more questions have come in. There's one that tangent to what you just said. From Anna, thank you. Does the savings exceed cost in maintenance systems?
Does the savings exceed cost? Yeah, I mean, typically we will see a complete payback on building automation systems. The ROI kind of varies again based on the volume of the project, but yeah, typically we do see a total ROI on these projects.
And John,
Chris,
you have a question.
Yeah, David, I'll just chime in here. So question for you, most of the BAS, I think that we're working with, they're part of the mechanical system. We've got lighting systems all throughout these buildings that have occupancy sensors on them. So as far as like programming the building, are there any systems out there that actually integrate those occupancy sensors, kind of like the way a Nest thermostat would work?
Yeah, and those definitely can be done. The lighting type stuff is very common, and those can be integrated. A lot of times those motion sensors are actually just wired directly into that particular lighting fixture, and it will enable and disable that fixture locally. Usually what we see in terms of lighting on building automation is scene setting or overrides when it comes time to shutting equipment off. We'll also do a lot of what's called daylight harvesting, where we'll actually put photo eyes inside spaces, and we'll look to see how much lighting is actually in a space existing. Oh shoot, I almost dropped you guys. We'll see how much lighting is actually in a space existing, and then we can adjust the light levels for particular lights to reduce them when we've got enough outside light that's already in a space. So I guess the short answer is yes, we can integrate those motions similar to what you said with the Nest. Fully integrated systems, actually thermostats a lot of times will have occupancy sensors on them as well that can be used for comfort optimization. And those same occupancy sensors can be used for lighting as well.
And I noticed Kyle Clinton has his hand up. If you'd like to unmute, feel free.
Yeah, I just wanted to kind of chime in, little shameless plug is they, for those of us that work in this industry, when you ask the questions about how much can I save, how do my costs relate to my return on investments, hands down, number one resource we need is your building benchmarked. You cannot manage what you do not measure. So benchmark and report the energy savings of your buildings. And those of us who work in this space can give you a much more educated estimate of what your savings potential is and what those costs are.
Yeah, I couldn't agree more. That's you hit the nail on the head. You don't know what you're saving until you know where you're starting. That's a good baseline. Always is a great jumping off.
Let's see. Chris looks like he's walking through the gates to his connecting flight.
I have a quick question too. And Kyle, thanks for that plug on benchmarking. And and tracking energy and use. Chris, are there incentives through Ameren available for building automation systems?
Absolutely. There are quite a few. A lot of incentives for building automation are what fall under custom incentives. There are some general plug incentives for things like variable frequency drives and things that would fall under the building automation umbrella. Most incentives through Ameren are custom incentives, which again kind of take into consideration all of the factors that we just kind of talked about. When we look at scheduling is a big part. How many run hours are we pulling out of it? Ameren will incentivize the hours that we pull out of a building. Are we doing advanced metering? If we're metering and monitoring the energy usage, Ameren will incentivize the program or the project more. There is incentives for the advanced programming sequences that I was talking about, the building optimization, temperature resets, setups, setbacks, all of that goes in there. Those programs change, every year or every couple of years, they reevaluate them. I believe on custom building automation incentives, and if someone more akin to the program may be able to answer this better than I can, but I believe on the custom building automation incentives, the incentive itself can be up to 50% of the total project. And I believe the payback on it has to be at least 18 months. And those incentives get to be pretty substantial. I'm actually calculating a couple right now. So my territory is all across Missouri. Basically everything that's not in Missouri or St. Louis or Kansas City is my territory. I'm doing an incentive project right now for a power company, actually a power company in Centralia. They're getting about a $40,000 incentive on a $100,000 project. And I'm doing another one for a school district in the Hallsville area that is actually looking at something very similar. They're looking at about a $38,000 incentive on about a $95,000 project. So, and again, you partner that, you take that incentive, that upfront incentive, and you kind of partner that with the with the ROI that we're talking about and the savings that we're talking about. And I mean, you can see in some cases, both of those cases, actually, those equipment that we're recontrolling is all equipment that's just running off of local, what I would call residential thermostats. Same thing you can go and buy in Home Depot and just plug into your stuff. So there's a lot of savings opportunity there.
If anyone else has any additional comments or questions, feel free to unmute yourselves or put those into the chat. Some very fascinating information being shared here.
I will jump in with another question, actually. So these building automation systems look fairly complicated in terms of like managing them from a building operator perspective. And so I just wonder, I mean, do you find that people are fully taking advantage of them? Do you think that there's more like workforce development training that needs to be happening so that people are using them more fully? I just curious about that.
Yeah, the building automation industry and a building automation system can be very intimidating. It's a very large system, as we kind of talked about just on the overview portion of it. There's a lot of information and a lot of equipment out there. There is, in order to fully take advantage of the opportunities for savings and all that, there is a little bit of buy-in that's needed from the end user level. Most building automation contractors provide training to be able to educate the staff to be able to support that building. So there is some training involved. There is a little bit of time investment involved to really get that to where you can really take advantage of it. But automation systems come in all different sizes, big and small. Even like it was my example with the church there, just a single air handler for a single chapel, all the way to to a 20, 30 story high rise, automation systems can kind of cover all of that. And I think any size of automation system, you're going to see some sort of savings on, whether it's HVAC specifically, whether it's lighting. Now, lighting, you don't see the savings that you do on HVAC. Like I said, in most commercial buildings, HVAC is about 40 to 50%, whereas lighting is about 10 to 15%. Especially buildings that already have LED lightings or motion sensors, as was previously mentioned. Those that are already ahead of the game a little bit on the lighting side won't see the savings really that you see on the automation side with automation that you see otherwise. But definitely savings there across the board. I have yet to see, unless it's programmed poorly, I have yet to see an automation system end up expending more energy than it saves.
Hey, Chris, can I ask you a question on the retro commissioning jobs that you're seeing? Just a couple things. So do you have kind of maybe a rule of thumb, square foot cost for adding in a BAS? And then when you go back for those retro jobs, do you find that you're doing a lot of it, gathering that information wirelessly? Because there's not, I assume that a lot of these retro jobs, there's no data running out to say these VABs, or there's no variable frequency drive, or there's none of that, in place, right?
Yeah, and to your first question, I don't necessarily have a number per square foot, just because it's all so different. Again, it's more based on the equipment and the volume of equipment. You can have a single space controlled by a single package unit, or a single space controlled by a VAB box, and the energy used for that single space would be vastly different. So it's hard to really say dollars per square foot for automation. Unfortunately, I don't have an easy plug number answer for that. For your second point, yeah, the retro commissioning does come in all shapes and sizes. Sometimes we do them on systems that have existing building automation systems, which absolutely makes it very, very easy to do. But in the other cases where it does not, there's a lot more overhead work that goes into it. Lots of eye tests on, let's say the example that I used before was an outside air damper, right? If I have a building automation system, I can see where that damper is commanded to, and most likely have a temperature sensor that will tell me what the temperature is that's being read when that damper is open and closed. If I don't have that, I've got to give it the eye check. I've got to actually go up and look at that damper. And in most cases, we do that when retro commissioning anyway, but look at that damper and actually visually see where that is set, drive it open, visually see where it ends up, drive it closed, visually see where it ends up, and then using some sort of a stick sensor or a probe, check those temperature readings. So without a building automation system, it's definitely more extensive of a project, but that doesn't mean that it can't be done. And just to kind of sidebar on this, back to the previous question about incentives, Ameren incentivizes retro commissioning projects, which is awesome. They want you to reduce your energy consumption, and retro commissioning is a great way to do that. Nice thing about the retro commissioning incentives from Ameren, they will incentivize the retro commissioning investigation, which would be that time that we're talking about right there, our time or whoever's time to actually come on site and investigate. They will incentivize that investigation time up to 100%. So the entire investigation will be paid for through incentive. And anything that we find as part of that retro commissioning process that you all then repair can also be incentivized as well. Very, very, very extensive I'm using too many big words at once. Incentives for retro commissioning projects. I highly, highly recommend them. If you're familiar with the workings of your building, if you have anything that runs 24/7, if you have anything that seems to be stuck open or stuck closed, and this doesn't have to be something that you're overly technical with. If you've got spaces of your building that are heating and cooling at the same time, most likely there's a problem that retro commissioning can correct. If you walk up to the building and the doors are being blown open on your building, you're having a pressure issue. Most likely it's because you've got something wrong with exhaust fans or intake air that retro commissioning can correct. Even a negative building where you walk up and you pull a door open and you hear that suction sound, there's problems going on in the building. So you don't have to be an expert, a technical expert. Anybody who's in buildings, if you're feeling comfort issues or seeing issues like that, those are the types of things that retro commissioning can help correct.
And speaking of the Ameren incentives, there is a link in the chat box, kind of going in more depth about the business types and the equipment types needed. And we are a little past 10:30 now, which we love because there's so much engagement. But Hannah put a wonderful question in the chat box if you'd like to unmute yourself to answer, or I can answer for you.
No, I was just wondering, Chris, what's the new thing that's coming up in building automation? What should we be ready to see in a couple of years?
That's a awesome question. Building automation is such a really technologically driven industry. So we always see a lot of things in tech that are really affecting us. As I mentioned at the top of the presentation, I'm just coming back from the from ASHRAE's AHR conference in Las Vegas, which is the industry go-to conference where everyone is showing what's hot and what's coming up. So great time to answer that question as well. We are seeing a lot of advancements in wireless communication, which I know seems a little rudimentary considering several of us are probably on wireless devices right now, but the wireless technology is really starting to take hold in the building automation market, which is going to do a lot for installation times, right? Everything that's hardwired all has to be installed. All that wire has to be maintained and purchased and all that. So we're expecting to see a bit of a decrease in installation time and all of that as this wireless technology continues to grow. We're also seeing a lot with Bluetooth. QR codes is another big part as well. We're seeing a lot of this stuff that is out there and it's already mainstream, but it's becoming more a part of our industry where you can actually walk into a space and scan a QR code with your phone and immediately access that particular specific piece of your building automation system and be able to start administering your system right away. So lots of that type of stuff coming. That's kind of what's next on the forefront, on the horizon for automation.
Thank you so much, and we are definitely looking forward to what the future holds, especially making green buildings better and building automation is certainly part of that. Thank you, Chris, for an excellent first coffee break of 2022. And
thank you, and thank you all so much for being so patient with me. I apologize again for the late start. And this is fingers crossed for me that I get home today. Just landed in Dallas. I was in Salt Lake City last night. I'm going to Little Rock next, and then hopefully. It sounds like you all had some weather there or something that's keeping us from coming home. So that's we've been trying to get out since Wednesday afternoon, and it's not going well, folks. So I hope to get back, but hopefully this wasn't too bad of a presentation given the circumstances. I do appreciate you all hanging with me, and that's the feedback and the questions and all that really means a lot. I appreciate you.
I would definitely appreciate you being part
astounding.
of it.
A testament to your focus and concentration.
Thank you.
Absolutely. And just an ending note in the chat, our next coffee break is the RSVP link are listed. We'll be talking about the St. Louis Green Business Challenge impacts into year 13 on Friday, February 18th at 10 a.m. And we definitely hope to have you join us. And immediately before then, on Tuesday, our upcoming evening educational program on the 8th, titled Resiliency Dependent on Equity, Applying National Lessons to Local Communities. And this is co-hosted with the National Society of Black Engineers, St. Louis Professional Chapter. So that should be very thought-provoking, and we encourage you to join us for that as well. And the RSVP link is in the chat. But it has been such a pleasure to do this coffee break for the first one of 2022, and we wish you all safety. If you're getting out in the snow or just relaxing a little bit, have a great weekend, and we will see you again soon.
Thank you.
Thank you.
Thanks everyone. Thanks, David, for hosting. Appreciate it.
Thank you, Chris.
Safe travels, Chris.
Thank
Yeah.
you.
Good luck
Thank
in
you.
the Little Rock.